This question is a binomial hypothesis test, but let's take a read through it and see what clues are there. So we actually know that this is a binomial hypothesis test because we're in the exam. Nothing's going to tell us apart from the words in the question. So Suzanne is a member of a sports club. For each sport she competes in, she wins half of the matches. So we've got that interplay there. Half of the matches, you could say she wins 50% of the matches she plays. So that's a proportion of 50%. Or you can interpret that as a probability. For each match she plays, she's got a probability of 0.5 of winning. So we always have those two views on a value like that, and we can switch backwards and forwards between them, proportion and probability. Okay, after buying a new racket, Suzanne plays 10 matches and wins 7 of them. So that already sounds like some improvement. On her prior data, on her prior statistics, we'd only expect her to win half of them. She should only win 5, but she's won 7. And the test is going to come down to whether that is a significant improvement or actually 7 is close enough in line with the 50% proportion from before. Then it says investigate at the 10% level of significance. So we've got a significance level. That's definitely a hypothesis test. And the instruction is to investigate, or sometimes they just even say the word test. Test at the 10% level. And what is it we're testing? We're testing whether the new racket has made a difference to the probability of her winning a match. So has made a difference isn't claiming positive or negative. It's just some difference. So this will be a two-tailed test when we write it. So the first part of writing a hypothesis test is the hypotheses themselves, H0 and H1. And these come down to the claim. So the original data, the old data was that she had a 0.5 chance of winning a match. So H0 is that nothing has changed, P equals 0.5. And we're asked to test with the racket has made a difference. So P is not equal to 0.5 anymore, is H1. And we ought to define what P is. So P is the probability of winning a match with the new racket. Now the sample information that we've got to make a decision on is she's played a sample of 10 new games. So we're going to have a binomial distribution where she's played 10 games. And based on the old data, based on the original data, she's got a 0.5 chance of winning each one of those games. So X here is a binomial distribution with 10 games and a probability of 0.5 for winning each game. So just before we continue writing the rest of the hypothesis test, let's take a slight moment on the side to look at the graph of that distribution and exactly understand why we're doing a hypothesis test and what it really means. So here on the side we've got a graph now of this binomial distribution. So this is binomial 10, 0.5. And each bar represents the probability of that outcome. So 5 in the middle, that's the highest bar, that's the most likely outcome. And it's also the mean. Remember, for binomial, you multiply n and p together. 10 times 0.5 is 5, so that's the mean and the mode all in the same place. But 4 and 6 next door, they seem pretty likely as well. They've got quite high bars. By the time we get to 7, they're getting smaller, and 9 and 10, for example, are tiny. So the question right now is, with her new racket, she won 7 games out of 10. Is that an extremely unlikely result? Or is that just nothing special? And back in our hypothesis test, the next things we write down are that we've noticed this is a two-tail test, and that means that we have to divide the significance level by 2. So it was a 10% significance level in the question, so therefore we're going to look at 5% tails each end. Now there are a couple of slightly different ways that you can finish this question, but I'm going to do it by looking for the critical regions, because you can be asked to do that in any question. So if we always do it with critical regions, we'll never get caught out. So to do that, you need your calculator to make a binomial CD list, or you can open up your formula book to where n equals 10 and p equals 0.5, and that's what I'm going to look at on the screen. So remember, the critical regions are tails on the graph, something like a tail down there at the lower end and a tail up here at the top end, where the probability of being in those tails stays under the 5% that we've got to look at in each tail. So at the low end, it's easier. So we're looking where n equals 10 and p equals 0.5. We're looking at this column in the formula book or on your calculator screen. And we're going to read down that column, keeping under 5%. So 0.001, that's fine. 0.01, that's fine, that's 1%. 0.0547, that's bad. That's got too big now. So it's only 0 and 1 that are good. So at the lower end, its x is less than or equal to 1. That's one part of our critical region. At the high end, we have to be a little bit more careful. So I'm going to point at this value on the row for 7. That's telling me that the probability of x less than or equal to 7 is 0.9453. But for the upper end, we need to think about greater than or equal to probabilities. So this one tells me that the probability of x greater than or equal to 8 is 1 minus the probability of less than or equal to 7. So it's 1 minus that number we've just seen, and that's going to be 0.0547, and that's too big. That's just over 5%. So we need to look at the next number down in the table, and that's the one on row 8. So I'm going to update my working so we can have a look at that one. So the table tells us that the probability that x is less than or equal to 8 is 0.9893. Therefore, the probability of being greater or equal to 9 is 1 minus the probability of being less than or equal to 8. 1 minus that number we've just seen, that's 0.0107, and that's fine, that is less than 5%. So x greater than or equal to 9 is our upper critical region. So we found both parts, x is less than or equal to 1, or x is greater than or equal to 9. So now let's go back to writing the rest of our hypothesis test. We've almost forgotten the story by now. So Suzanne used to win 50% of her matches. She got a new racket. In a sample of 10 matches, she suddenly won 7 of them, which is an improvement. And the question is if this is a significant improvement. And if we look at our upper tail, x greater than or equal to 9, that top end of the critical region, that's saying for her result to be significant, for her new racket to have made a difference, she should win at least 9 out of the 10 matches because it's x greater than or equal to 9. But she only won 7. So the next thing we'll say is that 7 is not in the critical region. Not in CR. It's not in the critical region. Therefore, this is not a significant result. So in your mind, you're thinking, okay, 7's a little bit better than before, but it's not better enough for her to claim some massive improvement. So her old statistic of 50% of matches, we don't have any evidence to change that view. So it's not a significant result. We do not reject H0. Do not reject H0. There is no evidence to suggest her new racket has made a difference. And remember, you must finish with that sentence in context to get the final mark in one of these questions.